Hi, I'm Brian Walton. I'm going to be sharing with you how to find the transformation of a function using a graph. Transformations of a graph usually involve translations, scalings, and reflections. A translation corresponds to shifting a graph, a scaling corresponds to stretching or squeezing a graph, and reflections have to do with flipping it either vertically or horizontally across an axis. I want to show you how to think of all of these transformations in a single way. So you don't have to worry about, for translations you add or subtract, and for scalings you need to multiply or divide, and then try to figure out which direction it is. There's a single way to take care of all transformations by using linear functions. So here I have an example of a function. I've got a function that I'm calling f of x, and its graph is this awesome w. And I want to figure out how to transform my graph so that my w has been stretched and shifted to the side in this way. And I want to think about this by using linear functions. The way that we'll approach this is by identifying 2 points on each graph that correspond to one another. So here, first I'm going to start by thinking about this point, and I'll call it A. And on my left graph, this is the point 0, 2. That corresponding point on the other graph, which is the middle of my w, is still A, but it's been shifted now to the point 2, 7. Now I'll find a second point, and I'm going to pick that to be this bottom corner. This is my point B, and on the left it's 2, 0. And on the right, that same corresponding point is 3, 1. So here I have my points, and I'm going to figure out how to transform them so that I am going from 0, 2 to 2, 7, and from 2, 0 to 3, 1. Now the other thing that I'm going to introduce is that on the left, that's my original function, y equals f of x. On the right, I also want to think eventually in terms of x and y, but I don't want to get confused about which variable. So my new x I'm going to call u, and my new y I'm going to call v. Our strategy to solve this problem, I've got, again on my left, I have points A and B. On the right, where those corresponding points are. And our strategy is we're going to use linear functions to relate how the x-axis changes, x to u, and how the y-axis changes, y goes to v. And then eventually we're going to use those to find our way of writing v as a function of u by thinking through the steps. U becomes x, x is transformed to y through the function f, and y is then transformed to v to get my final axis. So we do this in 2 steps. First, we're going to think through the function, how are u and x related? So we want to think of u becoming x, and so we're going to think of our points A, u started at 2, and that needs to become x at 0, and for our point B, u equals 3 needs to become x equals 2. Here we're focusing on the column u and x. This is supposed to be a linear function, so we calculate our slope. The change in x over the change in u is 2 minus 0, coming from the change in x, going then the change in u, 3 minus 2. And again, I have to be careful. I'm always thinking of the point B and A in the same order. B and A. So I get my slope now is, let's change the color back. slope is 2, and I have a point. Let's see, my point, I can use 2, 0. This allows me to get a formula for my function. X minus 0 equals slope 2u minus 2. This is my linear equation between x and u. Now I do the same thing for v, except this time notice I want to have y is my first variable, v is my dependent variable. So y and v, my point A, y equals 2 needs to become v equals 7, and my point B, y equals 0, gets transformed to v equals 1. I can calculate my slope, the change in v over the change in y. Alright, so we change in v 1 minus 7. Remember, I have to think point B minus point A, and then y, change in y, is 0 minus 2. So negative 6 over negative 2, my slope is 3. Using a point, let's see what point can we use. Let's use 2, 7. V minus 7 equals slope 3 times the change in y minus 2. In other words, v equals 3 times y minus 2 plus 7. If I simplify that, I get 3y minus 6 plus 7 plus 1. So this is my second transformation. Now we're ready to put the pieces together. I have my first step, u goes to x through the formula x equals 2u minus 2 times the quantity u minus 2. My function is what lets me go from x to y, and the second transformation, v equals 3y plus 1, gives my final formula. So how do I do that? Well, I'm going to take y equals f of x, and I'm going to substitute the formula for x. So 2 times u minus 2 is what goes into my function. Then I'm going to take that formula for y and plug it in. And so I get v equals 3y, which was f of 2 times x minus 2. Sorry, u minus 2. I should fix that. Okay. F of 2 times the quantity u minus 2 plus 1. This is the equation of my transformation. Now, if you recall, originally we wanted to think in terms of x and y. We changed the names to u and v so we could keep track of them. If I want to think in terms of x and y of my new graph, I just change the names for the purpose of the problem. So here is the formula for my new graph, my shifted and transformed graph of w using the variables x and y. And that's how you can do a transformation. You just identify points that you want to transform. You need 2 points so you can find the formula of the lines, and then you go through these same steps.